The last lesson that we had, we used a Desmos activity to see how the sine and cosine functions looked when they were graphed. Today we are going to graph sine and cosine functions using transformations. The first thing I want you to know are the values that I expect plotted on the parent functions of the sine and cosine graph. Take a minute, pause the video, and write these down. It's important that you know them. When you're ready, press play. Now, when we graph sine, we need to make sure that we have all the values that are in this chart plotted on my x-axis. So I'm going to draw them all in. And also on the y-axis, this is 1, this is -1, and we plot our points, and we draw a curve to represent sine of x. It's curved, it's not pointy. If I see pointy graphs, I will mark them wrong. Like this would be pointy. See the difference? Curved. The period we discovered yesterday was 2 pi. Not yesterday, but last lesson. The amplitude, remember, is the absolute value of a, which is in front of the sine, and it's 1. The domain, I don't think that we talked about, but the domain is all real numbers from -infinity to infinity, because this curve continues in both directions, and the range is from -1 to 1. It's important that you really know what this parent function looks like quite well. The next parent function we're going to look at is cosine of x. Now, again, we want our values labeled on our x-axis. So I'm going to draw them in. You also want them on the y-axis. And again, we're going to plot all of them and draw a curve, not a pointy drawing, curved way. So the period is 2 pi. We discovered that in the last lesson. And the amplitude here again is 1. The domain is all real numbers, just like sine, because the curve extends forever in both directions. And the range is from -1 to 1. Now, remember BCAD and what each of these values did. We discovered a little bit about this on the Desmos activity. Really, honestly, you should have known what these values did, but it was a nice refresher. More formally, make sure that you write this down. A is your vertical stretch, shrink, reflect. If the absolute value of A is greater than 1, it causes it to stretch. If it's less than 1, it causes it to shrink. If it's less than 0, it causes it to reflect over the x-axis. And then B is our horizontal stretch, shrink, and also reflect. If the absolute value of B is greater than 1, it causes it to shrink horizontally. If it's less than 1, it causes it to stretch horizontally. If it's less than 0, it causes it to reflect over the y-axis. C is your horizontal shift. If C is greater than 0, it shifts it to the left. If C is less than 0, it shifts it to the right. And D is my vertical shift. If D is greater than 0, it shifts up. If D is less than 0, it shifts down. Now, notice horizontal movement works in a counterintuitive fashion. Large values of B will cause a shrink versus small values of B will cause a stretch. Large values greater than 0 of C will cause my graph to shift in the negative direction, and small values less than 0 will cause it to shift in the positive direction. Vertical movement is very intuitive. Large values of A cause it to stretch, small values of A cause it to shrink. With D, if D is greater than 0, it goes up. If it's less than 0, it goes down. Okay, let's start by graphing this. So I'm going to identify what A, B, C, and D are. A is -1, B is 1, C is -pi/4, and D is 2. So my graph is going to reflect over the x-axis. It's not going to stretch or shrink at all horizontally. It is going to shift to the right, pi over 4, and up 2. So the first thing that I'm going to do every time I graph a sine or a cosine curve is I'm going to figure out the period. The period is always 2 pi, which is the non-transformed period, divided by b. In this case, b is 1, so my period remains 2 pi. The next thing I'm going to do is identify the amplitude. The amplitude here is 1. Remember, that was the absolute value of a. So it's 1. And then I'm going to figure out where I'm going to plot my values along the x-axis. Normally for sine, I graph between 0 and 2 pi. I would divide by b. In this case, it's 1. And then I would subtract c. And c, again, is negative pi over 4. So that's like adding pi over 4. So it would be from pi over 4 to 8 pi over 4 plus pi over 4 is 9 pi over 4. So now I know what values to put on my x-axis. Now, I'm going to also want to plot a value exactly halfway between these two. I'm going to find that by finding the midpoint. I find the midpoint by adding the endpoints up. And then dividing by 2. When I divide by 2, I find this is 5 pi over 4. Now I'm going to find a midpoint here between these two. Add them together. That's 6 pi over 4, or 3 pi over 2. Divide by 2 is 3 pi over 4. I can do the same thing here, or I can recognize that every single time I go up, I am adding 2 pi over 4. So this would be 7 pi over 4. Now that I have my x values along my axis, I would like to draw in a transformed x-axis. That is caused by my vertical shift here. My x-axis is going to shift up 2. So this value here is 2, is 1. So now that I have my transformed x-axis, I have values on my x-axis, the last thing that there is to do is plot some things. Now I got to remember that sine usually starts at the x-axis and goes up in amplitude, but I am reflected. So it's going to start on the x-axis, it's going to go down in amplitude, it's going to go back up to the x-axis, up in amplitude, and back down to the x-axis. So this starts on my transformed x-axis. It's going to go down in amplitude to 1. It's going to come back up to my transformed x-axis. Ooh, I screwed up. Do you know what I did wrong? I do. My first point starts here at pi over 4. I've shifted it to the right. So I start on my transformed axis. I go down in amplitude, go back up to the transformed x-axis, and then up in amplitude to 3, and back down to the transformed x-axis. So it is going to look like that. Notice it's not curvy. It's not perfect, but it's not pointy. Did I say not curvy? Notice that it is curvy. It is not pointy. My domain remains at all reals, negative infinity to infinity, and my range goes from 1 to 3. And that is how you graph a sine curve. Next, I want to graph this, except I think I am going to change this so now that it'll be 4 cosine of that. Let's see here if I can fit that in. Yeah. Okay, so write this down. Now, there's one difference here, in that I need to have my b factored out. So I need to write this as 4 cosine of 2 times the quantity. Each of these now is going to be divided by 2. Theta plus 2 pi plus 1. You know how you guys love theta. I mean, drops a lot, but it is a theta. Now, again, the first thing I'm going to do is figure out the period. The period is my original period of my graph, of my non-transformed graph. In this case, cosine is 2 pi. divided by b. So my period is pi. My amplitude is the absolute value of a, or 4. Now, I'm going to figure out the values that I'm going to put on my x-axis. I normally graph between 0 and 2 pi for cosine, but I have shrunk it. I have to divide by b. B is 2, so it's going to go from 0 to pi. And I've also shifted 2 pi to the left. So I'm going to subtract c from each of these. So that would be minus 2 pi minus pi. So drawing my graph, I'm going to graph between negative 2 pi and positive, or negative pi. So between negative 2 pi and negative pi. So halfway between these two, I'm going to find my midpoint. Negative pi plus negative 2 pi is negative 3 pi. Negative 3 pi over 2. Next, find my midpoint here and here. So negative 3 pi over 2 plus negative 2 pi is negative 7 pi over 2. Divide by 2, negative 7 pi over 4. I think I'm going to draw it. I'm going to make it smaller for myself. That's negative 7 pi over 4. Teenier. Okay, and that goes there. Then I'm going to need the midpoint here. So negative 3 pi over 2 plus a negative pi, which would be negative 2 pi over 2. That's negative 5 pi over 2. Divide by 2, negative 5 pi over 4. Now, last time we followed the pattern that sine goes, because that was the parent function. Now my parent function is cosine. Cosine starts up in amplitude, goes down to the x-axis, down in amplitude, up to the x-axis, and up in amplitude again. Now, one last thing I need to do is transform my x-axis up 1. Right there. Okay, so now I'm going to start up in amplitude. This is 1, 2, 3, 4, 5. Because my amplitude is 4, it's going to start up at 5. And it's going to go down to my x-axis, then it's going to go down in amplitude. 1, 2, 3, 4, down to negative 3. And it's going to go back up to my x-axis and then back up to 5. And then I'm going to draw it in my curve. This one's a little trickier to draw. See how it's curved? Okay, so now I need to write in what the domain is. It's all real numbers, negative infinity to infinity, and my range is from negative 3 to 5. Try this one. Press pause when you're ready to see the answer. Press play. And here's my answer. Notice my graph shrunk vertically. It shrunk horizontally. It shifted to the left, pi over 9, and it shifted down 2. Notice I have my values labeled on my x-axis and also on my y-axis. Here's another one to try. Press pause when you're ready to move on. Press play. Notice I had to factor out the b. So my period was 2 pi over this b, or 6 pi. I shifted my graph 3 pi over 2 to the left. My amplitude was 2. I also shifted my x-axis down 2. It started up in amplitude, which was 2, down, down, up, up, drawing the curve. Try this one. Notice you will have to rearrange it so you can easily tell what A, B, C, and D are. Give it a try. When you're ready, press play, press pause, press play when you're ready to see the answers. Here we go. So notice I had factored the B out, and it is stretched vertically, it is shrunk horizontally, it is shifted to the left pi over 4 and down 2. That looks familiar. Is it the same one? I can't tell. Is it? No, just looks similar. They all start to look the same after a while. And that is the end of our lesson. Check out your assignment on Schoology. The answers are also posted there. And I will see you tomorrow. Have a nice day.